Okay, so last class we were discussing about the six-membered heterocycles. So more particularly, saturated heterocycles. So suppose heteroatom is arsenic, then it's called arsenane. Suppose heterocycle heteroatom is antimony, then it's called antimonane. So the general method of preparation of this saturated heterocycle containing arsenic and antimony are these. So here the Grignard reagent, more particularly 1,5 dimagnesium bromide is treated with metal bromide. Here the metal is arsenic or antimony, and the obtained ones are called arsenine or antimonane. So similarly, it is, in other words, one can take 1,5 dibromopentane that was treated with disodium metal. Here the metal again, metal is arsenic or antimonane. So here there will be a new bond formation between the metal and then this carbon, and these two will go out, and there will be a new bond formation between this metal and this carbon. These two will go out, forming a product like this. So later, this one, it's a reductive cyclization. This sodium supplies electrons, and thereby there will be a formation of new bond between the metal and then carbon. So the obtained ones are arsenane or antimonane. So these are okay. All these are the examples of heterocycle containing phosphorus, arsenic, and antimonane. So with this, I will go to the one more concept. With this, I will go to the one more concept under heterocyclic compounds is called meso-ionic heterocycles. Meso-ionic heterocycle. I think you are aware about the mesomeric effect. So mesomeric effect means there will be involving the pi electron system. So here, here in addition to the involving the mesomeric pi electron system, there will be a involvement of ionic. Ionic means positive charge and the negative charge is involved. Okay, such compounds are called meso-ionic compound. The first example of meso-ionic compound is phenyl. Okay, so this is called phenyl. Yes. Okay, so this substituent is called phenyl, and name of this moiety is called phenylsidnone. Okay, this was first identified in 1945 itself by Baker and Oles. So it is not possible to write one structure for this phenylsidnone. So it is possible to write many canonical form or resonance form. It's because of the aromatic nature, and also a variety, a different from the aromatic also you can found. What and all you can found? Look here. So a negative charge here, and here there is a positive charge. And what you can observe here, 2 electron here, 2 electron here, and also 2 electron from the oxygen, or maybe a 2 electron from the anion part. Okay, that means this exhibit a resonance form, it's exhibit a planar one, it's exhibit a aromatic moiety. But what we are interested, we are observed that it's a two ions, a negative charge and the positive charge, and there will be a involvement of pi electron. So because of this kind of moieties are called meso-ionic. Meso term is obtained from the mesomeric effect. The mesomeric effect means involvement of pi electron system in a conjugation. And ionic, you know that since this moiety contains ionic. So that is the reason this type of effect is called mesomeric effect. So the compound to exhibit mesomeric effect means it should have a pi electron system, means a 5-membered ring, and it also contains a heteroatom, and it also contains positive part in the ring and the negative part in the outside the ring. That is the criteria for a compound to exhibit meso-ionic compound. So you need to remember that meso-ionic compound means it should be a 5-membered ring, and there should be a positive charge in the 5-membered ring system and the negative charge in the outside the ring system. Okay, such compounds only exhibit meso-ionic heterocycles. So you know that let's look into the canonical form. This anion can come over here and this can come over here. That means this anion will sit on this carbon as a anion. So that's what I have written. Now anion is here, cation is on the nitrogen. So then what will happen? This anion can come over here, and this bonded pair will sit on nitrogen as a anion part. So this is how the canonical forms are formed, and these are resonance forms also. If you want to write the resonance hybrid, so this is the one. I think you know that what is resonance hybrid. So the resonance hybrid will have a less energy compared to the canonical form. And so this is the resonance hybrid one, right? So this is only the first example of meso-ionic heterocycle. Okay, right. So definition means, as I mentioned, that it should be a 5-membered ring, and it will have a positive charge in the ring system and the negative charge in the outside. Okay, and right. So that's what. So then with this, I will go to the next slide. So next is about a general. Okay, this is the general molecular formula of meso-ionic compounds. What you can observe: A, B, C, D, E, F. Okay, the F is having an anion part, and the 5-membered ring will have a positive part. So that's what you need to remember. This is a general molecular formula of meso-ionic heterocycle. So suppose here I am taking the 2 examples. You can observe that it's a 6-membered ring. A 6-membered ring. It is also having a positive charge in a ring and a negative charge in a outside the ring. So similarly, this is also one more. You can observe a positive charge in the ring and negative charge in the outside. So, but these two, since these two are the 6-membered ring, and these two are not called the meso-ionic heterocycle, but these are called the meso-ionic B-tines. Okay, so 6-membered ring ones are called mesomeric, otherwise meso-ionic. Okay, meso-ionic B-tines. It's called meso-ionic B-tines, not the meso-ionic heterocycles. Okay, that's what you need to. B-tines. These two are 6-membered ones are called B-tines, not the meso-ionic one. So that you need to remember. So with this, I will go to the next slide. So if you are looking into the classification, this can be classified into 2 categories. One is type A meso-ionic compounds. Another one is type B meso-ionic compounds. So here, suppose a similar kind, okay, similar kind of heteroatoms are present at 1 and 3 position. Okay, that means not the adjacent. Okay, okay, here I will tell. Okay, if there is a adjacent heteroatoms, then it's called type B meso-ionic compounds. If they are in 1,3 positional occupies the similar heteroatom, such ones are called type A meso-ionic compounds. I will take one example of each type A and type B, and I will also mention the nomenclature, how we can name as per the IUPAC system to the meso-ionic heterocycle. So here I am taking one example. So what and all you can observe, this is a phenyl and 2 nitrogens, okay, are adjacent, and there is a positive charge in a 5-membered ring and the negative charge in the outside the ring. So name of this compound, a common name or a trivial name is called N-phenyl. This is N and phenyl. N-phenylsidnone is the name of common name of this meso-ionic heterocycle. And a name as per the chemical society. Chemical society, it is in UK. UK means it is not the Uttara Kannada. It is about United Kingdom. And the name, okay, how you can name meso, okay, meso-ionic, okay. So, and then you need to number. This is 1, 2, 3, 3 phenyl. 3-phenyl. And 1, 2, 3. 1, 2, 3. Oxa. Oxa stands for oxygen. And since the two nitrogens are present, diazolium. Oleum, why it is oleum? Because positive charge. And there is a fifth position. So 1, 2, 3, 4, 5. Fifth position, O minus is there. It's called 5-olate. Okay. uh, O-late. It indicates that O minus. Okay, so this is about the name according to the United Kingdom Chemical Society. So as per the new method, it's also called as meso-ionic. That's retained. 3-phenyl, it's retained. And 1, 2, 3 position of oxygen, nitrogens, that's also retained. Oxa it stands for oxygen. Diazole, okay. Diaza means 2 nitrogen. OLE is for the IUPAC nomenclature. OLE stands for 5-membered ring. And one, okay, one, 5-one, the fifth position, one indicates that CO group. Okay, this is also a method of naming as per the IUPAC to this moiety. Okay, so I will repeat again. So phenyl, N-phenyl is known is the common name. And as per the UK's Chemical Society, it's called meso-ionic. Okay, meso-ionic, 3-phenyl, 3-phenyl, 1, 2, 3 oxazolium, 5-olate. Okay, 5-olate. Fifth position, O minus is called olate. And new method means IUPAC method. Meso-ionic is retained, 3-phenyl is retained, 1, 2, 3 oxazole. Okay, here the difference between these two, here oleum is mentioned, positive part is mentioned, negative part olate is mentioned, but here there is no such thing. Here 5-membered ring suffix OLE is retained, and 5-one, okay, one indicates that CO group. So this is about the nomenclature of one example of meso-ionic compound. I will take one more. So one more is this. So here you can observe that there are four nitrogen, 1, 2, 3, 4. And there is a substituents at 2 position and the third position, 2, 3 diphenyl. Okay, 2, 3 diphenyl when it comes to a UK or the IUPAC nomenclature. But the trivial name means dihydro. Why it is dihydro? So because this N 2, 3 dihydro, because there is no double bond. Okay, the hydrogen is replaced with the phenyl group, dihydro. Tetrazole, okay, because 4 nitrogen is there, tetrazolium. Thione, okay, the fifth position, thione is there. Okay, that's what the common name, dihydro tetrazo thione can be the common name. But as per UK's Chemical Society, one should mention that meso-ionic, 2, 3 diphenyl, 1, 2, 3, 4 tetrazolium. Okay, fifth position, thiolate. Okay, since the sulfur is the one, it's called thiolate. The difference between the UK's nomenclature and the IUPAC one, only the changes in the suffix part. Suffix part here, tetrazole, OLE, end with OLE, and 5 thione. Okay, thione means sulfur containing ketone. So this is about the nomenclature. So now let's look into the another part. So that is how one can prepare this meso-ionic compound. It is possible to prepare meso-ionic compound starting with 1,3 dipolar compounds. This is called 1,3 dipolar compound. So diazomethane is a dipolar compound. So this means 1,3 dipolar compound react with cumulene. Cumulene. These type of compounds are cumulene. More particularly, heteroatom containing cumulines. Okay, that means 1,3 dipolar compounds reacts with heteroatom cumulene, giving rise to meso-ionic compounds. Okay. So this is about the preparation, and we will also discuss about the preparations of type A and type 2, and also we will discuss about the reactions of meso-ionic compounds. So with this, I will go to the next slide. So next slide here, I am talking about the reaction meso-ionic compound. When a meso-ionic compound, when it is react with alkenes, this is an alkene. More particularly, I am taking a substituted alkene. What will happen? So you know that 1,3 dipolar addition to the alkene. I think this is one method of preparation of heterocyclic compound. Uh, I think you may observe this kind of similar reaction in pericyclic reactions also. So what the name 1,3 dipolar addition itself is mentioned. Okay. So what you need to remember here, the anion part can attack this carbon and this bond pair can attack this atom. When this is attacking this atom, this bond pair will go on this carbon. Why it is going? Because it's a positive charge. So that is how an adduct is formed. The obtained adduct again undergoes retro addition. So retro addition means what? So you know that if this C is an heteroatom and if it is having a lone pair, that lone pair can come over here and this bond pair can come over here and this bond pair can come to this. So that is how again there is a formation of what is called as 1,3 dipolar compound. This 1,3 dipolar compound is unstable. This can be converted into a stable one. Suppose if R1 is having a proton, then there will be a proton shift from here to here. That means 1,3 proton shift. On 1,3 proton shift, a stable compound can be obtained. So otherwise, what will happen if there is a excess amount of alkene is present? The obtained 1,3 dipolar compound can react with the excess alkene, forming another adduct. So this is about the speciality of the reactions of 1,3 reactions of what is called as meso-ionic compounds with alkene. Okay. So with this, I will take one more reactions. The reaction is here reaction with heterocumulines. Okay. Suppose it is like this. Suppose STU. Okay. Yes, need not to be sulfur. It's an heteroatoms. T may be a heteroatom. U may be a heteroatom. Heterocumulene, when it is treated with the meso-ionic compound, what will happen? As usual, you know that here the two double bonds is there. But what will happen? This 1,3 dipolar addition add to only one double bond. Other will act as a substituent. Okay, so that means this anion can attack this heteroatom and this bond pair will attack this atom, forming an adduct like this. Suppose if it is if this moiety, okay, instead of S double bond T double bond U, if it is a S double bond T U inverted one, if this is upward, U is on the upward, then also it will undergo addition, forming a adduct like this. What it means? So addition of meso-ionic compound with heterocumulene leads to 4 isomeric product. Okay, these are two. Okay, these two, how it is obtained? So a 1,3 dipolar addition to this atom as well as this atom. So that means uh, T double bond U, when it is in the downward, you will get this product isomeric. T double bond U, when it is upward, you will get this isomer. So, and again, obtained these isomers are undergo retro addition. So that means, so this bond pair can come over here, and this bond pair can come to this, leading to a new meso-ionic compounds. So this method will give you a better option to synthesize a new kind of meso-ionic meso-ionic compounds. You can observe that this meso-ionic compound is different from this. Okay. Similarly, how this is obtained? This is obtained by the movement of this electron is can come over here, and this electron can go over there, and this electron bonded pair will sit on U. That is how a new meso-ionic heterocycle is obtained. Of course, this is a living group. Let's not worry about that. This is of our interest. So similarly, suppose T double bond U is on the upward direction, then this bond come over here, and this bond come to this position. So that is how this kind of meso-ionic heterocycle is obtained. So this is about the reactions of meso-ionic compounds with heterocumulene and alkenes. So with this, I will go to the next slide. So here I am taking an examples. Okay, so you can observe that what is the name of this compound. So 1, 2, 3, 4. 4 carbon atoms is there. Ethyl is there. Okay, diethyl. Uh, uh, what you can say that butane dioic acid. In addition to that, you have to mention at the second position YNE is there, that you can mention. So then what will happen here? Here what there will be a 1,3 dipolar addition to the alkyne, 1,3 dipolar addition to the alkene, more particularly heteroatom containing ones. So what you can observe now, this anion can attack this carbon, this bond pair can form a bond with this carbon, and this bond pair is going on the nitrogen and will sit as a lone pair. So it's a adduct formation. So and it is a pericyclic reaction. You can observe that here CO2 He, here CO2 He, and C double bond C. This group is here. Okay, and this moiety. Okay, this is going up. That is this. Okay, and this SCOCH3. Yes, COCH3 is this. Okay, here what I need to mention, right, it's correct only. What about this D? Is it a D or carbon? It should be a carbon. Okay, don't take it as a D. You can write it as a carbon. Okay, right. So then what will happen here? There will be a movement. Okay, that means it's called electrocyclic reaction. So this double bond means pi electron will go over there, and this this bonded pair will come over here, and this bond pair will come to this, and that is how a neutral product is obtained. It is a neutral product. A neutral product. This is not a meso-ionic one, and of course this is a living group. Okay, so then suppose This is a neutral product. A product is obtained when it is treated with alkyne with a meso-ionic compound. Suppose a meso-ionic compound, if it is treated with heteroatom containing one, so you can observe that uh, there will be a reaction, there will be a new bond formation between this carbon and this carbon and this nitrogen and this carbon. So that is how a product is obtained, and this product obtained one undergoes uh, movement, electron movement. That means this bond pair can come over here, this bond pair can go over here, and this bond pair will sit on sulfur, and that is how a newly formed meso-ionic heterocycle is obtained. This is having a application. So that means one can synthesize a new meso-ionic compound by treating with cumulene kind of uh, hetero compounds. So with this, I will go to the next slide. So next slide is about the synthesis. Okay. So next slide is about the synthesis, more particularly synthesis of type A meso-ionic compounds. So this is a meso-ionic oxazole. Okay. So you know that a five-membered ring with oxygen and nitrogen is called oxazole. Meso-ionic. Why it is meso-ionic? Because the positive charge, it is moving all around in a five-membered ring, and also a negative charge is there on the outside. So that is the reason it's a meso-ionic. How this can be prepared? You know that this is a starting material. What is the name of this starting material? You can observe that a carboxylic acid might is there. So adjacent to this carboxylic acid, there is a alpha carbon. So that means what we can say, that this complete group is called substituent. Then how you can name this RCO means acyl group. N means amino. So what we can say, that alpha acyl amino, alpha acyl amino, alpha acyl amino compounds react with acetic anhydride. Okay, this is an acetic anhydride. You know that acetic anhydride is act as a source of acetyl group. In addition to that, it also act as a dehydrating agent. It removes the water moiety in a it also act as a cyclizing agent. Okay, so what will happen here? There will be a reaction. How the reaction? Maybe the lone pair present on the oxygen, or maybe this bond pair can attack this carbon, and this, okay, this bond pair is going out. That means acetic acid is going out, forming a acetoxy compound. So once, of course, it can form a acetoxy on this as well as this one. So this takes the priority. Why? Because you know that carboxylic acid, it will be in equilibrium with carboxylate. Okay, the carboxylate means O minus. O minus easily can attack this carbon, and this bond pair going out as a acetic acid as a byproduct. That means O minus and H plus going out as a acetic acid. There will be a new bond formation between this oxygen and this carbon. This is oxy, and this is acetyl. Acetoxy compound is obtained. Then afterwards, it's a cyclization. How the cyclization? The lone pair present on the nitrogen can come over here, and this bond pair uh, can attack this carbon, and OCOCH3 acetoxy group is going out as a living group. And when it is going, it will also picks up a proton. Where the proton present over here. Okay, so that is how it picks up the proton, and this bond pair can come over. This bond pair will sit on this carbon. That is how anion is formed. So this is about the preparation preparation or synthesis of type A meso-ionic compounds. Okay, this is what obtained. So with this, I will go to the next slide. So next slide is about the meso-ionic oxa. Okay, what is this? O and sulfur. O and nitrogen. O and nitrogen is called oxazole, and O and sulfur is called oxathiols. Okay, oxathiol, oxathiol. Okay, right. So this is about the preparation or synthesis of oxathiol. How it is obtained? It is by the reaction of, okay. This is thioacyl. Okay, maybe how you can say that, oxy. Okay. Of course, this is a carboxylic acid and this is a alpha carbon. Okay, alpha carbon, what is the thiocarbonyl? This is called thiocarbonyl and this is oxy. Thiocarbonyl oxy, alpha thiocarbonyl oxy, when it is treated with acetic anhydride, it leads to the formation of oxathiol. So, as usual, similarity is there between this and the previous one. So previous one, there is a nitrogen here and there is a oxygen here, but now there is a oxygen here, there is a sulfur here, that's all. So what as usual, the lone pair present on the oxygen can react with this carbon. There will be a new bond formation between this oxygen and this carbonyl carbon, and this moiety is going out as a byproduct. So that is how a intermediate formed like this. So oxygen also is having a lone pair. That lone pair can come over here, and this bond pair attacks on this carbon, and this O acetoxy will go out as a byproduct. So it won't go as such, it will take the proton, okay, thereby leads to the formation of anion. So this is how a oxathiol is obtained. Again, oxathiol is a meso-ionic heterocycle, and this is belongs to type A. Okay, meso-ionic compound. So with this, I will go to the next slide. So next slide is about the thiazole. Okay, thia means sulfur, aza means nitrogen, OLE means a 5-membered ring, and it is a meso-ionic. Why it is meso-ionic? Because it contains positive and negative charge. More particularly, positive charge in a 5-membered ring and negative charge in a outside the ring. So how this can be prepared? You know that a compound. Okay, C double bond N means it's called what is called, if R2 is equal to OX, then it is called oxime. If R2 is equal to N, it's called hydrazone. Okay, so then what will happen? As usual, the anion or the lone pair react with this acetic anhydride, and this group will go out as a living group. There will be a new bond formation between this oxygen and this acetyl group. This is the intermediate is obtained. At this moment, the lone pair present on the sulfur can come over here, and this bond pair attacks this carbonyl carbon, and this will go out. So that is how an intermediate is formed. The acetoxy picks up this proton, and this bond pair will convert as a anion. So that's what that is how the thiazole, thiazole 5-membered ring, thiazole, and it's a meso-ionic compound is obtained. So with this, I will go to the next slide. So this is a method 4, or more particularly dithiol. Okay, 2 sulfur containing a 5-membered ring is called dithiols. Okay, so how this dithiol is obtained? By treating with the thioglycolic acid. Okay, name of this compound is called thio. glycolic acid because of the presence of this sulfur, thioglycolic acid. So this thioglycolic acid, when it is treated with acetic anhydride, as usual, the lone pair present on the oxygen will react with this carbonyl carbon, and this is a living group. It will go out along with this proton. Acetic acid is a living group. Then what is a intermediate is formed like this. At this moment, the lone pair present on the sulfur will come over here, and this bond pair attacks carbonyl carbon, and this bond pair, along with this bond pair, acetoxy is going. While going acetoxy, it will picks up a proton. So proton present over here. So this after picking up a proton, the bond pair will convert as a anion. So that is how a dithiol meso-ionic compound is formed, starting with the thioglycolic acid and acetic anhydride. So with this, I will go to the next slide. So next slide is about